Let us go through the graphical representation of velocity, displacement and acceleration. For that, we have to first calculate what are the values of displacement, velocity and acceleration at different times in a cycle, that is at time is equal to 0, time t by 4, t by 2, 3t by 4 and t. Upon calculating those values from that data, we will draw the graphs and show how the graphs are different or if they are same for the values of velocity, acceleration and displacement. Let's calculate. Now we know that y displacement is equal to a sine of omega t and velocity is equal to dy by dt, that is equal to a omega cos omega t, and acceleration a is equal to dv by dt, rate of change of velocity, that is minus a omega square sine omega t. What does these mean? This has been already discussed in the previous lectures. Now let us calculate. At time t is equal to 0, at t is equal to 0, the value of displacement is equal to a sine omega t, that is a sine of 2 pi by t into 0. We know that sine 0 is equal to 0, so the value of displacement at t is equal to 0 is equal to 0. Calculating the velocity at t is equal to 0, v is equal to a omega cos of 0. Cos 0 is equal to 1, so v is equal to a omega. Now calculating the acceleration, acceleration is equal to minus a omega square sine of 0. That means a is equal to 0. So at t is equal to 0, y displacement is equal to 0, acceleration is equal to 0, velocity is equal to a omega. Now at time is equal to t divided by 4. Now the displacement is equal to a sine 2 pi by t into t by 4. T and t goes, it is pi by 2, sine of pi by 2 is equal to 1, so y is equal to a, velocity is equal to a omega cos omega is equal to 2 pi by t into t by 4, that comes cos of pi by 2 is equal to 0, so velocity's value is equal to 0. Acceleration is equal to minus a omega square sine of 2 pi by t into t by 4, that is equal to sine of pi by 2 is equal to 1, sine 90 is equal to 1, so a equals to minus a omega square. T equals t by 2. Now displacement is equal to a sine 2 pi by t into t by 2. T and t goes, 2 and 2 goes. Sine of y is equal to 0, so y is equal to 0. Velocity is equal to a omega cos 2 pi by t into t by 2. T and t goes, 2 and 2 goes. Cos pi is equal to minus 1. That means v is equal to minus a omega. Acceleration is equal to minus a omega square sine of 2 pi by t into t by 2. That is equal to sine pi is equal to 0. So acceleration is equal to 0. At t is equal to 3t by 4, our displacement y is equal to a sine of omega t. Omega is 2 pi divided by t. into 3t by 4. T and t goes, it becomes 3 pi by 2. That is a sine of 270. We know that sine of 270 is equal to minus 1. So displacement at 3t by 4 is equal to minus a. Now v velocity is a omega cos of omega t. That is a omega cos of 2 pi by t into 3t by 4. That becomes a omega cos 270. We know that cos 270 is equal to 0. So velocity at 3t by 4 is equal to 0. Acceleration is given by minus a omega square sine of omega t, and sine of omega t is sine of 270 degrees as calculated in the displacement above, minus a omega square sine of 270. We know that sine of 270 is equal to minus 1, so minus into minus is equal to plus, so a is equal to a omega square. So the acceleration has got the value of a omega square. Calculating the values of acceleration, displacement and velocity at t is equal to t, that is a full cycle. Y is equal to a sine of 2 pi by t into t. Here t and t goes. Sine of 360 is equal to 2 pi radians is equal to 360 degrees. Sine of 360 degrees is equal to 0. So y is equal to 0. Similarly, velocity is equal to a omega cos of 2 pi by t into t. Cos of 2 pi or cos of 360 is equal to 1. So 1 into a omega becomes a omega. And the acceleration accordingly is minus a omega square sine of 2 pi divided by t into t. Sine of 2 pi is equal to 0. So this whole function is equal to 0. So acceleration at time t is equal to 0. We have got the values of displacement, velocity and acceleration at different times. When t is equal to 0, t is equal to t by 4, t is equal to t by 2, 3t by 4, and t is equal to capital T. So we will draw a table and we will show their graphs accordingly. Now the values of acceleration, velocity and displacement got at the times 0, t by 4, t by 2, 3t by 4 and t are drawn in the form of this table. Let us plot the graphs. Plotting a graph of the displacement, we see that it starts from 0, goes to the maximum value, then to 0, then to minimum value, then to 0. As it starts from 0, so we will be having a sine function. That means we will be having a graph that will start from 0. So the graph is plotted as this. So this is the 0 value, this is the a value, this is 0, this is minus a value, and this is 0. Now plotting the graph of the velocity as seen has got a maximum value at t is equal to 0. That means it is a cos function. So if it is a cos function, it means it starts from the maximum value. That means when we plot a graph of the velocity, it starts from the maximum value. Let this be velocity plus that it is velocity minus. It starts from the maximum value at t is equal to 0. So the graph is like this. This is the maximum value, that is a omega. At t is equal to 4, it is 0. At t is equal to t by 2, it is minus a omega. At t is equal to 3t by 4, its value is again 0. And at t is equal to t, the value is a omega, that is this value. Plotting the graph of acceleration, it starts from 0, goes to the negative value, then goes to 0 value, then goes to positive value, then goes to 0 value. Here, like the displacement graph, it will start from the 0, but instead of going into the positive direction, it will go into the negative direction. That means the graph is like this. This is 0 value, minus a omega square, 0, a omega square, and 0. This is the graphical representation of displacement, velocity, and acceleration. Here, velocity leads the acceleration by a phase angle of pi divided by 2. Now, the displacement leads the acceleration by a phase angle of pi degrees. This is all about the graphical representation of displacement, velocity, and acceleration.